Today we're going to show a new exciting feature of SDC Verifier. It's the optimization module. And with this optimization module, all the power of SDC Verifier can be combined in an automatic optimization process. And I want to show you together with Pavlo how that is working. Okay, what is the general idea of the optimization module? And so the idea is, okay, with SDC Verifier you can check designs and models according to rules and regulations, but the change it is without this optimization module only a situation check. So whether something fulfills the standard, yes or no. With this optimization module, we can do some extra nice things. Is that instead of making one single design, we can set a set of possible member sizes and shapes, and come up for each part of the model with the most economical member of that selection or of that size. So instead of making a single model, the SDC Verifier checks for each selection, or whether it's a component or a material, or for example, all vertical members, or all members which are part of a certain height, or even if you want for each beam member, you can let SDC Verifier decide shape is the most optimal based on the maximum stress results or the maximum utilization factors according to the standards you need or you want to use. In this example, we're going to show we're going to use the Eurocode 3, but all other codes of SDC Verifier which are implemented are of course available for the same optimization idea. And even if you want to use your a more complex own set of rules, you can set up your own standard and optimize according to these set of rules. SDC Verifier uses selects for each member. It does the check again for each different properties, and then comes up with the best solution, and recalculates based on that new shape what are the results. And in the end, you can automatically update your design with the optimized new design, which of course will weigh a lot less. Okay, to be a bit more specific, if in this example we're going to see for a lattice structure, what we can do, you can set, for example, for here the rail members of this crane, a set of possible profiles you would like to use, and then for example, all the diagonals, use something else. And so based on, and we use the powerful selection method of SDC Verifier, you can specify exactly what do you need where, and where do you want to use, for example, round shapes, where do you want to use closed box sections, and where you want to use eye shapes, for example. It's also good to mention that the standard tool sets of SDC Verifier make this process much easier. Yeah? If you have, for example, a couple of 100 cases, using first the governing load sets, that reduces that overall set of load sets into a much lower set of relevant cases where which these relevant load sets give a maximum somewhere in one of the elements which you want to optimize. Yeah. So for a quicker process, it makes sense to use first the governing load set and then reduce this the total number of load sets into the relevant one to greatly enhance and quicken up the solution using only the relevant loads, which reduces this optimization process to a fraction of the original calculation time. I want to give the word now to Pablo, who is going to show how this is going to work in reality. And I hope you enjoy this new exciting feature of SDC Verifier. Pablo, I want to give the word to you.
Yeah. Hey, hello. So I will start to share my screen.
Yeah, I need to stop sharing. Yeah, I did it.
So now you should be possible to see my screen.
Yes, I do.
Okay, so first of all, I will start from brief explanation of model which was used in this example. So this is simple lattice structure, basically done using only beam elements. In general, we use like circular tubes, I-beams, and rectangular tubes in this model. Was applied few fem load, so it gravity load, wind in that direction, force down applied here on this I-beams in points, force on top part, and you can see it divided over full top structure, top floor, and also force to the middle horizontals. Also, last one is wind in X direction. So now we are going to SDC. Based on this fem loads was created 4 load sets. So if you want, you can easily edit all these load sets. Basically, load set, this is linear combination of FM loads with taking into account some factors. In this table, you can clearly see which factor used to which fem load in each load set. Then, to take into account worst situation, all these load sets were combined into load group. So, using this load group further, we will make check according to Eurocode standard.
Pablo, maybe it's also good to show the complete matrix of load sets, just to give a quick overview.
You mean this one?
Yes.
Yeah, so here you can see all load sets. You can easily edit it here or add extra one.
Okay, so you have different situations with either wind from the Z direction or wind from the X direction, and what else changes?
Basically, it changes only direction of wind.
I see. Okay, so you have the standard load situation, and the only thing what changes is the wind. Okay, so for this example, you can see that the loads vary from any direction. Thanks.
Yeah. Our optimization tool works on selection. So to make this check, I prepare some components. So I will show. We will not check full model, but we will check some parts of this model. And this, first of all, we will check all vertical tubes. Then we will check horizontal I-beams. Also, we will check top floor rectangular tubes. Also, we will check crossing tubes and diagonals.
Okay.
So First of all, I want to present results of Eurocode check on original model. So from this table, based on this selection, you can see the utilization factor for worst utilization factor for all of these components. And what we want to do next, we want to optimize the shapes. So for horizontal and for floor beams, we definitely need to change to a bigger shape just to get that shape past the check. And for crossing and diagonals, we can use smaller shapes with smaller area to get just less weight of total of full structure. So in the end, we should get at least or smaller weight of our structure, or at least it should be the same, with taking into account that we will increase area of this two components.
Okay.
So now we're going to optimization tool.
Could you also show a plot of this
sorry.
the utilization factors, because that gives you a better idea?
Yeah.
I get it correct, is the results which are above 1 are not okay, while the ones, if you have components with a value way below 1, they are probably too strong and so too heavy.
Yeah.
That's correct, no?
Yes, that's correct.
Okay. So if I see this, I would expect that the top I-beam should be slightly bigger.
Yeah, top beam should be slightly bigger, and also this horizontals here should be bigger. These two are not in our selection, so it will not change it. The results, but yeah, this one will be updated to bigger.
Okay.
Okay, so let's go to optimization tool. So I already prepare this setup, but yeah, I will show how to add new one. So basically you need to click on that button, and first of all you need to select on which lot you want to make this check. So we will do that on a lot group, which include all lot combination. Then you need to select which standard you want to use. So in our case, we might check according to Eurocode 3, so we will use standard Eurocode 3. Our optimization will base it on backlink and overall check and parameter.
Okay, but it's basically all these, I see this, these are all the results according to the calculation according to Eurocode, no?
Yeah.
So shear, axial, bending, buckling, and then in the end you combine everything.
Yes.
Okay.
So here you should select a limit for utilization factor. So you want that it should be below 1. And basically that's it. So next, at variable option. So you can make your optimization based on cross-section area or unit modulus or yield stress. So we will take into account cross-section area, and we want to get minimum value of cross-section area. After that,
yeah, so that the resulting weight is the lowest.
Yes, exactly.
Okay.
So in the end, you should select on which part of model you want to optimize to check. So as I mentioned, I made components. For example, if we'll take horizontals, so we select that we want to update it based on shape, and you see a list of all cross section which we have in our program. So here, using filter, we can find shape which we want to use. In my case, I want to check IPA I-beams. I know that horizontals now in model used is APA 400 and it doesn't pass the check. And for example, we will start from IPA IPA 450.
Yeah.
And also we can add other in bigger shape. So for example, IPA 500, 550, 600, and I think, yeah, for this case it's enough. So just press OK,
Mm-hmm.
and that's it. So you can see in selection, so you will, that this component, this part of model, on this part of model will be checked all the shape which was selected here.
Okay.
So after that you press OK and you see that you have this optimization tool set up here. But yeah, I will remove this because yeah, I already have one created in for our in our case, and you can see so all which component I will check. So I will leave vertical tubes the same, but I will check horizontals, floor beams, crossing, and diagonals.
And if you want to add these elements which you say you were not going to optimize, can we change that as well? The ones you add also this formula, the select the elements which were already too high, and add these to this presentation. Can you do that?
Yeah, we can. You can select it like from model.
Yeah. Because they're all the same shape, no?
No, this is different shapes.
Okay. Yeah. I see. Yeah, there are different shapes. Okay, so you can select by clicking.
Yeah.
But
So
can you also select by beam member or not?
You can select if you have it recognized. Okay, so we will add some additional selection using beam members. So we select members by element. It means when you select one element from this member, it automatically will select all elements which lie on this member.
Okay. So the selection tool of SDC Verifier also greatly helps using optimization as well.
Okay.
Yeah.
So now we can preview.
Yeah.
So yeah, as I mentioned, by selection one element, you select full member.
Okay.
So then we should select shape which we want to check. So this in original model, this is IPA 300. So I think we can try to check also on IPA. And we will start from IPA 330. Then 400, 450, 500, 600. I think that's it.
Okay.
Okay.
Yeah.
Okay, and you can see that we have one more extra selection for this.
Okay, and if I get it correct, then you select these two members. They will have the same shape, no?
Yeah, yeah.
Okay, and if I want to select a single member and select that single selection, maybe that beam member in the middle, so can we optimize that as a separate unit?
This beam member already included in selection.
Ah, okay, that is with the horizontal ones.
Yes, yes.
Okay, but if I would have liked only that, then I should make a separate selection only for that beam member.
Yes.
Okay, get it.
Okay, so basically that's it, and we can run optimization tool. So by selecting what calculation you want to do, press calculate, and it will start to calculate. Yeah, calculation time depends on the amount of elements selected, and also on the amount of rules which was selected.
Yeah, because for each shape you recalculate the rules for every selection or every shape you want, no?
Yes.
Okay. And in the window below you can see the list of calculation, what is calculated and what is not.
Yeah.
Yeah. Well, you have this window in front, but if you could have moved it before, then you cannot move it now.
No.
Okay.
But also you can see here what calculated in the meantime. So you see that now start calculation component 2 and which shape check it now.
Okay, so there is enough info to see how far you are, and it gives you also a nice idea of the overall expected time. And in this example, we keep it short, but if you want to do this on a one-on-one for every beam member, something else, of course, that's not very handy in production, because then having all different types of shapes everywhere does not make life easier. So this combination actually is a nice way or to keep conformity. And if you really want for certain elements to have more shape or more selections, you could do that.
Okay, so we are done now. Now we can check results. So what we can see, we can look on optimal results. So it means it will show you a result based on that optimization with lowest value of area and utilization factor. Also you can check all results, and also you can check all results by element. So let's start from optimal results.
Yeah.
So now you can see, so all utilization factor below 1, and it show you'll also here shape which is acceptable and optimal for our model. Also, we can check all results. Here you can see detailed results for each of selection, so you can see which shape pass check, which shape doesn't pass a check.
Okay.
And yeah, so this is detailed.
Okay, so if we go to that last beam 58, beam member 58, that is the single selection, and then the IPA 330 was way too small.
Yeah.
And IPA 600 was just fine.
Yeah.
Okay.
So after that we can close this window. We can automatically update all the shape in our model by pressing this button, change beam shape. So after updating beam shapes, you can see this model in space claim with all updated shape, which was calculated based on optimization tool. So after that, you need to update your model into workbench and rerun your analysis to get new results with new shapes. And after that we can check results. We can rerun a standard check in SDC and check new results. So let's look first on table results. So all utilization factor below 1 is acceptable. Also, you can check plot. Okay, so now we can see new results. So all elements which was before was high utilization factor now updated. So this small piece we skipped, we didn't check it. This is local overshoots. And after that we can prepare some small result report.
Yeah.
So I already made some simple brief report where I just show material property which was used, also component which was used in our optimization tool. So after generating,
okay, here so here see you the result in a small report document.
yeah.
Okay, so you end up with the table and the plot.
And what? Yeah. Yeah, but
Yeah.
we need to
Okay.
update this view. Or yeah, we can export this to Word and also make this generate the same report for original model and just compare our results. So here is results for updated model. And let's generate the same report for original model.
Okay, yeah, so here you see the results which are not okay. And you end up with a table of and a plot which everything is fine now. Okay.
So if we convert to Word,
Okay.
to compare. So that how look model after optimization, how look results, and not for original model.
Okay. Very nice. I think you've shown a nice example of how you could use our optimization tool. If you have more information, if you need more information on SDC Verifier, or you want to see more of SDC optimization tool, just send us an email and ask for a trial, and we're happy to provide you with one, and to see in your own model how this drastically speeds up your design process. Thanks. This is it, and I hope to see you on another webinar on SDC Verifier. Bye.
Yeah, bye.